Hi Renee, this is your feedback for the topic test that we just did in class. I'll just get a pen opening here. Areas to work on definitely, but there's some good things as well. You comfortably come up with the Cartesian equation. The domain of the Cartesian equation is the range of this, and the range of this is 3 to negative infinity, so minus infinity to 3. And the range of this will be the range of this, which should be 0 to infinity. As a result, we needed to draw this in this direction. You've got that y-intercept can't be negative 9 on 2, it's got to be positive 9 on 2. But you got your starting point here correct, except you drew the line a little bit too far. Over the page, we are wanting their acceleration to be perpendicular, so we are wanting to look at r dot dot of z dot r dot dot of a to equal 0. I can see you've tried to do the velocities, and also you tried to do velocity and acceleration, but we wanted the two accelerations. Over the page, I got 37, you got negative 27, so there's a little bit, I can see a 37 there though, but it's the wrong I coordinate. To the question speed, you've given me velocity. So if this was your answers, you'd need to do the square root of 31 squared plus 7 squared to give us speed, because the speed is the velocity magnitude. To find an expression for the position, we're going to take the velocity, but needs to be i's and j's. We're actually integrating well, there it is there. However, we do have an initial velocity, which is this. So you need to work with your d. And again, difficult to get the last one when you don't have the equation. Question number 4, look at the projectile notes. To find out the angle and the speed, we've got to work with this. I've got to find the position vector by integrating this, and then adding in the fact that my position was at 0, 0 to start off with. So we need some equations. Question number 10, this is the correct derivative, but the graph has to be a cos curve. So it's going to look something like this. This is the correct equation. This is going to be a negative sine curve. And then, of course, you don't have these because you didn't have the graphs. Question number 6, you've got a correct drawing, which is good. We just need to work on how do we get the areas under the curve. Question number 7 is using lots of questions to do with how do I do a replacement for A, and I need to generate velocity. So take the derivative. In this one here, I don't know how you got 2.31, because if you make t 0, you get 4 on root 3, and the acceleration, if you make t 0, gives you an acceleration of 0. To the next one, we needed to integrate this from 0 to 10, because this is the velocity. The area under the velocity curve will give you distance. We needed to have our replacement for A, and in this case I'd be using v dv dx. And this one we have v, and we need the acceleration, so I'm going to use the same thing. A equals v dv dx. So check the substitutions for acceleration, and again some perpendicular, velocity and acceleration. So you needed to find the velocity and the acceleration and do the dot product and show that you get a 0. And over the page, that's correct. maximum and minimum speeds again. To find the speed, it's going to be the magnitude of the velocity. So we're doing the square root of this squared plus this squared, and then use Fmin and Fmax. Have a look at my solutions and then see if you can do the same thing on the calculator. Some good things here, Renee. There's also some gaps that we need to work on between now and November. Keep it up.